Hey, everybody. We're going to have a fun and exciting panel for you. We've got some great people on the panel today, Simon, Morri, and John. I'm going to let them introduce themselves a little bit. So I asked them to tell us a little bit about what kind of data they're dealing with in terms of the nature of that data or the types of data that they're interested in looking at, the scale of that, and then what they are doing with it, what kinds of questions they're interested in answering, what kind of features that enables, what their technology stack looks like. Just a brief overview of that so that everybody knows kind of the lay of the land. And then also any sort of, I don't know, philosophical or anecdotal opinions or ideas about data, because this is sort of what we're hoping to capture in this panel is our relationship to data, how we think about it, the nature of the data that we're dealing with, what we are doing with it, and then how that plays out in terms of our technology stack and our ideas about data. Does that make sense? Okay. So we'll use this as a baseline, and then we'll see where the conversation goes. We want to keep this very conversational, so we've got 3 mics. Hopefully people will be sort of interjecting and we can find some interesting conversation points and dramatic tension. Okay, great. Take it away, Simon.
Hi. Currently I work at Metabase, which is a Clojure, open source Clojure BI and analytics tool. So kind of my current perspective on this is, I guess, just looking at how people are using Metabase, and it turns out because like we're open source, there's this huge variety of usages. Like on the one hand, we have people using like tiny databases on like some Heroku, on those free tier instances with like maybe 100 rows or something. And on the other end, I think our biggest users have databases on like order of magnitude of 100 billion rows or something like that. And now kind of the challenge then for us is how to build tools that fulfill the needs of both groups and help both of those groups kind of surface interesting things. And like my exact sort of mandate at Metabase is essentially to build a data scientist in a box. So what we're trying to do is we're trying to automate a lot of the kind of tedious parts of just analyzing the data. And it's kind of going to your point asking about like what do you actually want from data? This is like a question that I daily am kind of asking myself. Just like how to get interesting insights from data and also just what it means that data is interesting for a human. And kind of, I guess my views have sort of evolved since starting to work on this project, and now I'm kind of, I guess like I still call it kind of the data scientist in a box, but I feel that it's more and that's more about kind of building tools for actually human augmentation. So like the question that I'm now asking myself is like how can we change the way we work with data, and like what are the things that are kind of just unnecessary and essentially like in a programming context we'd call them just like boilerplate, and you can get away with them, and how then if you mention that, like remove all the tedious parts of analyzing your data and like working with data, like how does this change how you fundamentally work, and like what kind of insights can you get from that? Because like we are still limited. I don't know, like those of you who've been to my talk yesterday, like I said, that like I know that I can't hold much more than a screen worth of code in my head. And I'm pretty sure that there's kind of same limitations also apply to working with data. You're kind of limited. And so the things that tools help you surface, like fundamentally change the things you can extract from data. And that's kind of an area that I find like vastly interesting. But I know I've kind of drifted away. So kind of to get back to the point, like just because of this kind of huge variety of databases that we work with, what we try to do is we try to push as much computation as we can to the actual data warehouse, because also like the assumption here is that if you have a lot of data, you probably also spend considerable amount of time optimizing your data warehouse, so it kind of makes sense to try to do as much as you can there. But we do also like realize that like the smarter we want to be with data, like the more processing we'll have to also do on our side. So this is kind of a still, I guess, an open area for me, and just a kind of looking back at my past experience when I was working like, as a data scientist, and on the other end, like actually having my own data, like I'm a huge proponent of Onyx, which I think is like a wonderful piece of Clojure technology and like a very Clojure-like take on just how you work with massive amounts of data. So I'm kind of flirting with kind of introducing something like that when we want to do kind of much more complex processing of things in Metabase. And kind of like the last thing, and this again also kind of ties both to my past experience and the things we're trying to build with Metabase is, that I think like the overall, like if you look at the ETL tooling, so that like the way that we acquire data and transform it and finally kind of load it in our databases is like even though there have been made like huge strides have been made, it's still, I think the kind of the mentality is way too much locked on something kind of like a script-like world without much real introspective qualities. So what I'm kind of interested about is like how can we also build tools for that? I'm a huge proponent of notebooks in various different contexts, from onboarding people to actually kind of using them. And one thing that I found like very useful in like my previous job was to essentially have the entire ETL process be described like as a series of notebooks. So you have kind of you can see at each step what's happening rather than just having this kind of very opaque system runnings. And that's kind of some of the learnings from this is also like we're now kind of attempting to add to Metabase to kind of use the same visualization exploration capabilities we already have to also do at least some kind of rather primitive ways of ETL, but kind of fully introspectable and much more interactive than it currently is when it's just kind of locked into some complex pipeline.
That's really interesting. Cool. We're definitely coming back to many of those points that you highlighted, including the data notebook approach to this, and how to build a data scientist in a box, which I think also means how to empower people to bring their understanding to the data, and then to through that continue to refine their understanding about the data. That's really interesting. Yeah, please.
Sure. I'm Morri Feldman, and I work at AppsFlyer. We provide a software as a service for the makers of cell phone applications that allows them to track the effectiveness of their advertising. And it's based on a SDK that we give them and they embed in their app. And then for the lifetime of the cell phone install, we get messages back from that SDK. What this means in practice, for me, I work down in the trenches in the data team, and so the stack has a front end with many web servers that are continually accepting the data from these cell phones, which currently we're talking 70 billion events a day. Once you compress it into compressed files, 35, 40 terabytes of data a day. Right. So yeah. It's a really a challenge to manage it, shovel it around. Right. And I think I have obviously a lot of interesting things for me to say, but I think in terms of one of the big separations that we have to make at this scale is and it occurred to me listening to you talking about Metabase is sorry about that, the separation between raw event level data and the aggregated data.
Right.
And every time you make an aggregation, you're making a trade-off, right? You're giving up some information from the raw data so that you can access it more quickly. So right. We have dashboards that need to show data in a few hundred milliseconds. We have other dashboards that need to show data in tens of seconds. Right. We have queries that can maybe, for internal use, maybe would take half an hour. And all of these use cases, you have to tune the trade-offs as you prepare the data.
Right, right. So you said something like 100 billion per day?
Around 70 billion
70
per day
billion.
events right now.
And those events, how complex are they? Do they tend to be pretty simple?
They start off fairly simple, and I skipped a bit of our stack. They come into web servers and then are quickly loaded into Kafka, and then from Kafka they go from one topic to another with small services in the middle that are enriching them. Right. With the help of key value stores that are holding the state of the system. Right. And then all of that flows down to me and the data team where we persist it out to S3 and then work on it in the format of Parquet files, columnar files that are optimized.
So they start off fairly simple at the top, and as they're aggregated, they also get enriched.
Yeah, they get enriched, and throughout, we're currently using just JSON message format. We can discuss that
Right.
more. But
And at the level of the data team, what are the questions that you're interested in answering?
So the main dashboard is a bit annoying from a developer perspective. It's a lifetime value of the cell phone install. So what that means is that and this goes back to your concept of a bitemporal database, right? We have the install date, and then we continue to receive events from an install, but they all need to be referenced back to the install date. And this is an annoying, basically means that you need some type of a mutable or evolving store. And so it's pretty challenging to present that view to the clients.
Right.
So.
Oh, sorry. I was actually hoping that John would grab this mic, or vice versa. The mic mastering in the middle is complicated. Just so that you could reply on mic if you
Okay, cool.
to.
What reply to that is that point? Or should I just riff in general?
So, Morri, why don't you tell us about your tech stack, and then we can do an asynchronous reply on John's.
Oh, sure,
part.
yeah.
Sure.
So I think I covered most of it. The web handlers are written in Clojure, and then the services in between that enrich the data are also written in Clojure, and they speak with key value stores. And then we receive the data and write it out to these Parquet files that are columnar. So that means that if you only want to reach a certain column of the data, it's cheaper than a row-based format.
Okay. Right. Cool.
And then we run many Spark jobs to aggregate the data for each of the different products, and the lifetime value view is one of those products. But we also have a product where we look at the retention of the install over time, and other products.
Interesting.
Yeah.
Okay. Cool. Thank you.
Sure.
Cool. My name is John. I work for a consultancy called Juxt. And yesterday we launched a product called Crux, which helps to give you views of bitemporal data. So dealing with that problem that you described, that you have these facts, and you have the ingestion time, the transaction time, but then you actually care about the time that those facts were created. So Crux attempts to help with that problem. I was just thinking before this panel, how we work with data. And I guess I'd attempt to summarize it really by saying that there's two types of data that I typically see across our projects. And one would be the kind of fine-grained data that's produced by machines. So this is like the sort of lean, austere sort of facts, the tuples.
Right.
And they need some enrichment, they need some processing. But then you get the data which comes the other side that's written by humans, and that's just always a mess.
Right.
You get some documents, it attempts to fit to some schema, but it always needs tidying, there's duplication. And they're kind of two different worlds. On one you have events and facts, and on the other one you have these documents.
Right.
And you treat them differently. I was just randomly thinking about one project where they had this trading dashboard, and it cost a huge amount of money each year to basically maintain this dashboard. And it was really complex. It sort of grabbed all this data from all these different machines and databases and displayed it in a very complex way. And these traders had to come in and work with it. And they had to produce this report at the end of each day to sign off the end of day report. And one trader said, I can't actually propose to my wife because each day just takes me so long to go through the end of day reports, the analysis, and I have to open up these tables and pivot around and change these equations and dig in. So our project there was to produce a dashboard that sort of brought the humanity back in a way, instead of all these grids and pivots and all this complicated stuff. I mean, it looked impressive what this dashboard did, but it was very sophisticated. But instead, what the traders wanted was just show me where the problems are. Just show me what I have to do.
Right.
So at 5 o'clock the end of the day, I can just log on, do what I need to do, sign off, and then go home.
Right.
So that was the project, but it was more about just this person being able to propose to his wife. Like, that was really what motivated us each day.
Right.
And in the end, we gave him an app, so he didn't actually have to be at his machine. He could just do it on the train on the way home.
Right. Right.
So yeah.
So he could keep the app open while he was proposing. And
Yeah, exactly.
Yeah, yeah.
He could
Right.
do it via the app, maybe.
Uh-huh.
I don't know. But yeah, just sort of, when the data is produced by machines, we have to find a way to give it to humans. And then when that data is produced by humans, we have to figure out a way to sanitize it and make it usable by machines.
Right. That's a nice way of putting that.
Yeah.
Yeah.
I guess those are the two sort of problems that we deal with.
So if I understand correctly, the dashboard that they were dealing with gave them the power to be able to answer the questions that they needed to answer. But doing that was a very cumbersome manual process.
Yeah, it was kind of the opposite. Instead of sympathizing with the machine, which the first incarnation of the app did, where it just said, hey, here's all this data, here's everything that's going on, but then they had to understand from a human perspective what they needed to do with that data.
Right.
We just reversed it, and we just had a nice sort of material card design and just said, look, this area of the financial information is red, you need to solve this problem. This one's green, don't worry about it, just relax, this one's good.
Right.
And then as people said, well, I need to understand this nuance, this could be a problem, we just built more and more checks into this dashboard. So it became more of a sort of, you're flying a plane and you have a cockpit and you can see the dials. You don't want to know every intricate detail of every single thing that's happening. You just want to know, are we going to crash? Like, is everything good? Is everything green?
Right.
And then react to problems as they present themselves.
Right. Morri, on your side in the dashboards that you're presenting to your end users, do those tend to be static or are they highly interactive in the way that John's talking about those dashboards?
The interaction is often on the level of drilling down. So you'll look at the data from, say, a top level, and then maybe you want to split it out by country or split it out by the media source, be it Facebook or Google that brought you the installs, or then you want to split it out by lower level features like campaign. And so all these dimensions that you can split the data out, these end up really being where we have to negotiate with the product and find the line, because these determine how big is the aggregation. So if you take your data and you add a new dimension, if that dimension has maybe 50 values that it can take, that can potentially split every row that you're looking at by another 50.
Right.
If it only has a few values, then it's maybe cheaper to give them that. And so trying to find the right level of that aggregation that we are preparing is a tough issue.
Interesting. Right. So you have to sort of prepare that ahead of time, otherwise you would have to re-aggregate.
Exactly,
To come up with an answer for them. And that may take hours, potentially.
Yeah. So the initial aggregation does take hours, and then it's ready to go, and the queries are.
Do you keep it sort of at is there like a bottom aggregation level? And then if someone asks for a value higher up, like suppose they ask for continent level statistics, is that aggregated on the fly from country level statistics, or are you pre-populating all of the fields?
We're pre-populating all the fields, I think, if I understand.
So as you go from the top level and you break it down and you're seeing more and more detailed views, all of those values, the top level ones, the more broken down ones, all of those are calculated ahead of time.
Yeah.
You're not aggregating the lower level views on the
No,
fly.
we have thought about, if I understand correctly, kind of picking exactly which combinations of dimensions we would support. Like maybe we'll support, just to give you a concrete example, you could say, well, we'll support the campaign dimension, but we won't support it combined with the country dimension. And then you can kind of pre-calculate different slices that are cheaper, right? But we haven't gone down that route yet, because inevitably someone says, well, I do want to see it by country, and they can't really understand your limitations
Right.
that you put on the data.
Right, right.
Maybe another part of this is the cardinality of the dimensions is very important.
Mm-hmm.
So and we're exposed to the outside world here, so our clients can put really whatever they want onto the clicks that they're sending us. And so if they populate the campaign field of the click with a UID that changes every click, and they send us 10 million, then suddenly we have 10 million junk rows in our database.
Yeah.
And so we have a batch process that for every client, it puts a limit on how many campaigns they're allowed to have, and it actually orders the data by business criteria and says, well, these are your best campaigns. You can have 3,000 of them, let's say. And then below that, we'll just replace these UIDs, if that's what they were doing, with some constant value exceeded limit.
Right. So that you can start to get aggregation that's
Yeah.
meaningful for that
Yeah,
client.
because if you have aggregation without limiting cardinality and you're exposed to the outside world, you basically just have raw data, and you
Right.
haven't simplified your problem any.
Right.
So
So it blows up your system and it's not meaningful for your clients.
yeah.
How important is it in a system like that that you give exact values to clients as opposed to approximate values?
Yeah, I think approximate values are often quite good. One difficulty in a system like ours, where we are sort of calculating different aggregations for different views of the data for different product teams, is that someone was looking over here and they say, oh, I see I have 1,000 installs, and they look over here and it says 1,005. That's actually more of a problem than whether the 1,000 was accurate.
Or precise enough.
Yeah. It's
Interesting.
the discrepancies between things that are more important. And so that's one of the challenges with going to approximate solutions. So,
Interesting.
although, they would definitely be a big win in a lot of places.
Yeah, it seems like it lets you relax certain things that are complicated to maintain those guarantees of preciseness. If you can just go for accuracy, then interesting. So in your system, you're mostly, in some ways, constrained just by the amount of volume that's coming in. And you're limited in the ways that you can deal with that in sort of a nuanced way because there is so much of it.
Yeah.
Simon, I think in some ways the system that you've described is almost the opposite. You have almost unlimited ability to deal with complexity. How does that change your concept of like dashboards and interfaces and ways to interact with data?
Yes, because we can't make many simplifications that you otherwise could have, because we simply don't know that the field is so wide open. And it is like, for instance, like what you're talking now, this notion of doing approximations. It's something like, if I were working as a data scientist or someone kind of leading some data department, I'm very much in favor of that. Like, I think that having super precise, exact answers everywhere just doesn't make sense. Or even if you claim they're exact, they're just like, you're still probably plastering over some forms of imprecisions that are inherent to just how you collect data. So it doesn't make sense, and the trade-offs are huge in terms of how much more performant you can make things if you use various sketch algorithms and things like that. But having said that, we as a tool, we can't make that call for you, because there's still there are some use cases. For instance, a lot of Metabase is heavily used in the medical field because it's one of the few on-premise analytics tools, and they need that because of compliance. And in those cases, sometimes you actually do want a very precise answer. So it's not something we can commit in advance. It's kind of this constant tension, I suppose. On the one hand, us wanting to build kind of more advanced things and like even like imbue some intelligence into it. And but on the other hand, like it still needs to be like, you have to be precise, because otherwise, or at least kind of communicate those things well. We're now kind of starting to experiment with some things where we give you, let's say, predictions or some kind of estimates of what's going to happen. Let's say, like, if you have partial data for the current month, and we'll kind of give you a prediction of what we think the end value, the value at the end of the month is. And this presents like huge UX problems, because you want to kind of communicate that in a way that is clear. This is no longer an exact value, but rather something that we kind of project. And also, like, Metabase is literally being used all over the world. And so you do have this kind of various cultural differences to which you also have to account for, and make an UX and in such a way that this is something that's kind of meaningful to them, and that kind of people realize what's actually going on. And like, in some ways, like, I know I'm kind of copping out with this answer, because it's like it's a super hard problem, and we just like, I don't have the answers of kind of how to do this absolutely right. But I do think, like, one thing that I value very much in Metabase, and what just kind of excites me when I'm building it, is that how general purpose we are. Because like, what it turns out is that people find so many kind of new ways of how to use it, essentially as kind of a building block to solving their problems. And then when we go and speak to our users, it turns out like that, you know, you have all those kind of small inefficiencies and frictions in your process, maybe not as severe as the poor bloke who couldn't propose to his fiancée, but like, there are those like small inefficiencies where you waste 10 minutes of your day, 15 minutes of your day, and there's just like simply no tooling. And then people find something like Metabase, which is rather malleable, and they can just kind of apply it to their problem. And maybe it's something that's not kind of even analytics per se, but it's just a question of how to get data from some data store where you don't kind of have a tool to view that. Or where previously you were kind of relegated to asking your development team to do a report, or just like pull the data out, and that incurred massive friction because you had to issue a ticket and I don't know, waited for the next sprint or something to actually get that data. And now those users are just kind of empowered to do that on their own, and they can, you know, like, with those small tweaks, they can change how they fundamentally work and use data and what kind of data is available to them. And that's kind of this kind of notion of just kind of building small tools for your usage. Like the same thing, I guess, kind of we do in the Clojure world. We're kind of, you know, constantly extending the language itself to be more what you need to solve your problems. And kind of building those kind of tools for other people who might not have been as technical is something that I find kind of very, very fascinating. And definitely, like, it's a feature of Metabase I don't think it's worth kind of sacrificing to just kind of maybe be more better at working with like super huge amounts of data or something like that. Like we are kind of aware that we are kind of, like, there are always going to be like needs where you need much more advanced visualizations, like what we can do. And this is kind of for us, it's a very conscious decision that we're kind of limiting some of the capabilities, because the more kind of complex you go, both in terms of the visualization you use, the types of analysis you allow your users to do, those all incur a very significant UX penalty. And it oftentimes just kind of doesn't make sense. Like if you look at something like Tableau, which has like fantastic visualization capabilities, but it's also rather intimidating. And it's not something that someone, let's say a manager in a call center will not use Tableau to analyze their kind of daily operations, because it's just like, the tool is intimidating, and just like the friction of using it is too much. While if you give them something much more simpler, with where the flow of just using the tool is much better, like let's say Metabase, for instance, they will kind of tend to use it, and they will put usages which like maybe their data department didn't even thought of. And this is also like talking to people actually now using Metabase. I kind of now looking back when I was in the role of like leading data departments, I still saw that even though I was doing kind of interviews then, but there's still like so many blind spots where you just don't kind of realize that you could have applied data to some of the problems that people are having, but now that they can just, you know, without learning that, because it allows them to do it themselves, they just say, okay, but maybe I can kind of do this and that. And that's kind of great that you have this kind of completely bottom-up way of breaking down some of the silos that you tend to kind of occur with in bigger organizations where they have kind of a lot of data.
So you're in, if I understand correctly, you're in an interesting position here because you don't have to deal with the operational concerns of the data, the ETL side of the data. You're a layer above that people can hook into their data warehouses or databases and then ask questions about that and come to an understanding about the data. In a perfect world, not necessarily what you have right now, but in your dreams, what is the ideal ergonomics around that interface of the person and their ability to ask questions about the data and receive answers look like? You mentioned notebooks, for instance. How does that work in this ideal world?
Like, I think in programming terms, what you would want would be kind of a very declarative way of working with data. And like, even we have just made very small steps in that direction. But if you look at the kind of fundamentally how we're working with data now, it's very much kind of in this empirical, kind of this way of just kind of saying, okay, like now into like this column and that column and can apply this aggregation, like all those kind of steps you have to spell out and think through that perspective. And just what we do and the flow of analysis tends to be way too much dominated by the topology of your data, which might not, I mean, if you have a data warehouse, it might, if you're lucky, it's already kind of, the data is organized in a way that's pretty nice to do analysis on. But the moment you have any other kind of data set, like the concerns that went into the topology might be completely different, and you're kind of stuck with them. And that, but unfortunately, that also then shapes the way you think about your problem and how you approach it. And those things, I think, are kind of completely, not just kind of unnecessary in terms of like the friction they give you, but also I think they kind of exclude some of the venues of how you would analyze and interact with data, or if you have kind of a more, I'm not going to say abstract, but an approach that's kind of more kind of human-centric and just kind of talking about data. Like one thing that I love, and even though it's kind of just the framing, like in Metabase, we say that you ask questions from your data. Like you don't build reports, you don't kind of do some of that, but like you ask questions. And I think that's kind of fundamentally the right framing. That's something like a very interactive process, like kind of a dialogue with your data. And like this kind of dialogue will inherently, like will have to abstract over many of the more operational concerns because those are just kind of noise.
It's the right framing for doing what?
Just kind of doing analysis, like how you kind of approach as the approach data as a user. I think that still kind of a lot of the analytics, like both software and just like what we do in data science, like does show its kind of its genealogy of being kind of born from essentially programming and programming-like tasks, and it's kind of oriented way too much on that. But it is like, I don't think kind of this is actually the right approach. But having said that, I also think that, and now I'm going to go like way too wide, but just to throw it out there, I think also like a lot of the things we do, like in terms of programming, is kind of wrong and too low level. Like if you compare to other engineering disciplines where they have computer-aided design and things like that, it is kind of the way other engineers build things is vastly, vastly different from the way that we build it. And like the way that kind of tooling helps someone like design an airplane or something is kind of completely different than like if you look at our tooling, it's like it's kind of pathetic compared to what other kind of systems can do. And so I'm kind of interested in like, okay, so what would be essentially like, what would CAD for doing data analysis look like? Like what that kind of system, but also like ideally maybe without all the kind of necessary complexity, but just kind of how can kind of tools help you rather than just kind of being there. And maybe like they are phenomenally powerful. Like the things we can already do with data is fantastic. But at the same time, like you have to kind of know what to do and kind of get in there and grab it out rather than kind of being like the affordances are rather poor. And I think this is kind of an area where a lot of change can be made. And it is kind of also like it is feasible. It's not one of those, yes, it would be ideal if this happened, but it's like, yes, like probably if like we sit down for a long enough time, if we speak with people, like just kind of collect like different impressions of how currently people are working, where they're kind of suffering, where are their best insights from, like maybe we can kind of glimpse of some of the ways that we can make tools with much, much better affordances than what we currently have.
So, yeah, that's very interesting. So if I understand correctly, you know, what you're doing is essentially trying to find ways to maximize the person's ability to have a conversation with that data, give them as many affordances as you can during that, make that conversation as natural as possible so that the person can learn and dynamically interrogate the data, ask questions of it as they're learning. Morri, in your case, you're really constrained just by the volume and the operational concerns around this. And if someone wants to ask different questions about your data, then you've got to retool your entire system to allow them to do that because you have to re-aggregate things in a different dimension.
Yeah, or, you know, there's latency that you can trade off for that.
Right, sure. So
if
they
you
could
wanna
wait a
ask-
few hours.
Yeah, if you want to ask questions and you're willing to wait long enough, then, but that has its own problems, right? Like doing something exploratory if it takes 20 minutes, it's really
Right.
hard because you get back the answer and you're like, oh, it's just not quite what I wanted.
It changes the nature of the conversation
Yeah.
completely. Even 10 seconds delay
Yeah.
changes the nature of the
Yeah.
conversation. If
Yeah.
you're talking to somebody on the phone and you've got 10 seconds delay versus
Yeah.
less than a second delay,
Yeah.
that's a very different type of conversation.
Yeah.
And I think that's true with computers too.
Yeah.
If you're working in a REPL and you've got to wait 10 seconds for a round trip, it's a different experience.
Yeah.
Right? It qualitatively changes it. John, I think you're kind of in the middle in some ways, in that what you described earlier was a system where you wanted to find some kind of balance between the users being able to interactively explore that, but also giving them the right insights up front. How do you decide when you're looking at a problem how much to put into the machine in terms of its understanding of the data and the canned answers, and how much to put in terms of the UI for the users to be able to explore that interactively?
Yeah, I guess it's a good question. It's quite a hard question.
That's what I'm here for.
Yeah. Well, I think to Simon's point that we're just trying to understand tooling better and get to be more advanced, to get better at those tools. I think I sort of worked my way up to that question. I think what's occurred to me is that we're still understanding just basically how to work with data, and
Right.
it kind of surprises me just how much we misuse data in some ways.
Mm-hmm.
So, for instance, you might start with a project or a team, and everyone's like, "Let's go for microservices. Let's sort of have like these REST APIs, and each service will have a repository." And then somebody from the business will sort of rock up and say, "Well, I just want to ask this question." Perhaps one of Simon's questions that Metabase would be able to answer.
Right.
But then the devs are like, "Well, we have to do some wiring between these microservices. This microservice has to call that microservice, and then maybe the APIs aren't there, so we'll have to add a new REST API." And that's before you even consider the actual database that's being used. It might be that, we've got one database that's being used for everything, for the
Right.
event log, but then also the sort of materialized views and to answer those hard questions.
Mm-hmm.
So this conversation that you guys are having it's almost like way above like where most of the industry is, because most of the industry has just got their data locked away behind these services that's impossible to get at.
Right.
And I'm just enjoying this part of the industry because I still think it's still interesting. Like, we're still advancing. So GraphQL is an improvement on these kind of microservices, these RESTful ones, and now we're getting to a point where people are creating these single GraphQL dashboards and entry points where you can query and explore your data.
Right.
And that doesn't solve everything, but at least it's a better way of just having a general question and being able to sort of work out your own answer without having to consult a programmer to add a new API for you, to create some new rules for you. And as I talked about yesterday with Crux, I think it's just understanding that time is so fundamental as well and plays a huge role. That's just one more factor in how we work with data.
Mm-hmm. Mm-hmm.
So I feel like I'm along for the ride, really, just understanding and witnessing and watching, just as an industry, how we're improving working with data. And that's extremely interesting to me.
Where do you see that trajectory going over the next 5 or 10 years?
I think streaming is obviously a huge factor.
Mm-hmm.
It's so often that people think, right, I just want to have this system display these changes to my users, and that system obviously, has to then go to some data store. It has to do these background jobs. It has to maybe create its own sort of representation of that data.
Mm-hmm.
But I think life would be so much easier in lots of cases if we just really embrace streaming. So we have this event log of events happening across the business, and these services just hook into it, and they register their projections and updates of those views, and then they can then just push those events to the people that are interested, the users. I think this is obviously non-trivial. Like, it's a different world. These
Right.
constantly updating materialized views. How do we build them? What are the technologies that we can use to help us?
Do those projections that the services are creating go back into the main event log, or are they siloed off?
They could be siloed off. So, if you look at the tooling around Kafka, for instance, like KSQL and Ktables, you can register a SQL query, which works against the main event log, but then it is creating a localized store that you can then go to interrogate. So, yeah, this idea that you have the event log and then that might spin off some other topics and some other materialized views, and it goes on, and it's this rich sort of seam of data that's coming in, and these different services and even humans could augment those events and those views as they go through. I think is a very interesting dynamic.
Right. That is interesting. So, how is that different than what we have today? I mean, this. If I want to sort of draw some picture or something, or have some visual analogy that highlights the difference between what you're describing and the world as we see it today.
Well, I think people are very quick to sort of build an actual database. Like let's get hold of some data.
Yeah.
Let's have our own local database. Let's have our own store.
We want a pool of data somewhere.
Yeah.
And you're describing almost more of a series of tributaries and streams.
Yeah, I mean, the whole GraphQL thing is kind of opening it up. So instead of having a single database that one team or one service owns, at least with GraphQL, it might be a federated database. It might pull together those sources and then present a single view. But going beyond that, it's good to question, like, why are we so quick to silo our data in the first place? Like, why are we so quick to have all these different stores and these different services that protect those stores that sit in front of them? I think just opening it up and having a data lake that anyone can go to and run their queries, I think is something that we're seeing more of. But in terms of how it looks, instead of these different lakes all over the place, like you say, we have the streams, the tributaries, and then people just collect that data and then they push it. They might not even hold on to it. There might be no need. They might get more stateless services. Just the data comes in and they pipe it on. They display it to their users.
Right.
Yeah.
Yeah, I wonder how much of this is still tied to our underlying concerns around persistence and storage and, pushing things over the wire, somehow feeling, all of this somehow feeling unstable.
Yeah, I think one thing is, like, we also have to separate out the concerns of our data fabric. So if you look at a database, it has a few things going on. You have this transaction log. You have an event log. That's what the database does when the data comes in. It just writes it down, so it's got it there forever.
Right.
And then it will index it and create some materialized view. And I think it's this whole concept of the database inside out. When you've got so much data at scale, it's like it just makes more sense just to pull apart those concerns.
Right.
And then maybe, yes, we want the transaction log, but then the materialized views might be different based on the consumers. And if we break it up and turn it inside out, then we've got more options to play with that data.
Right. So we almost just get persistence as a given. Anytime anything hits that area, you persist the transaction log that event occurred.
Yeah.
But then what happens after that is all sort of transient. It's just flowing through.
There was a classic case of one client where they had a single table inside of a database. It was Oracle, and they used it for everything. Like, they used it as the sort of transaction log, the event log, kind of bitemporal sort of features in there as well. And then they use it for query. And in the end, it was just like it did neither of those things well, because there was so much data in there that you couldn't really query it. You could do one type of query only, and even then there were people patching it, adding indexes and storage just to make that work.
Yeah.
And it would have been so much easier if they just split apart those concerns and just say concern A is getting that data and just storing it. Let's put it in some event log, and then we've got it, phew, right? Maybe that event log has some semantics, like we can replay it, we can easily consume it, but let's just deal with that problem. And then everything becomes a little bit easier because that's taken care of. Then you can think about how you build views off the back of that, to help ingest it.
Cool. Morri, from your perspective, down in the trenches, what do you see happening over the next 5 or 10 years?
I'd like to see ETL get more declarative, at least than what we're doing. Obviously, I've seen some talks where people are getting to more interesting declarative things, but we're using Spark jobs that consume data from S3, write data back out to S3, and then those jobs are organized into a DAG in an airflow scheduler, and this is all really like, do this, then do this, then do this, very imperative.
What would you
And
like to be able to say?
I guess I'd like to be able to say, this is what I want. I want a report where, I have these fields accessible with this type of latency, and it'll hopefully go figure it out based on underlying places where it could choose to get that data.
Right.
And
So you would say something like, I want aggregations along these different dimensions
yeah,
with these cardinality limits, and
Yeah.
do it for me with this amount of latency.
yeah,
And then, assuming this is trivially parallelizable or
Yeah.
something, it will go and spawn enough things
Yeah,
to make that
yeah.
happen.
and then do it every day, or
Right.
yeah,
Interesting.
yeah.
And yeah, I wonder what, that's interesting. I wonder what the expression like of that looks like in its
Yeah.
in its kind of most basic and simple and eloquent form.
Yeah.
What do you really want to say there to
Yeah, I
describe
think that's
that?
part of why we don't have it yet, is we haven't figured out what we really want, but we know we don't want what we have now.
Right,
So
right.
we know we have either too much or too little or
Yeah,
the wrong shape of abstractions.
yeah. And maybe part of figuring that out is continuing to understand these interactive conversations, because as
Yeah.
part of that, you may figure out how to do that expression over time in ways that really are maximally simple somehow. What do you see happening over the next 5 to 10 years, Simon?
Well, I definitely expect more automation or kind of things magically happening, because like right now we're doing way too much grunt work and just kind of figuring some things out. Also, like I'm kind of hoping that we'll reach this inflection point where for a large class of users, like you will not have to choose between representations that are kind of technically feasible or kind of optimizing just for the performance versus kind of the layout of the data. Because like I was thinking about like when John was saying, like, and ideally like what I would want in a database, like as a data scientist or whatever, like is it should basically like it should be it should allow you to get anywhere to jump to any point in the history. So like you want kind of this bitemporal capabilities. You want it to be updated live, so you kind of want this streaming capabilities as well, and kind of, but you want everything at the same time. So kind of essentially like sort of like what you have like in a SQL database or something, like kind of all those features, and but at the same time, but as like. And at this point, like these features are something that give value to the analyst, but I don't also want all the kind of cruff with it that's just there because we right now have trouble kind of making it work on a large enough scale. And I'm kind of hoping that just the amount of data that we produce won't still kind of outpace the speed at which kind of our computing power is increasing, and that we can actually kind of have nicer databases, because otherwise, like, I think like kind of if you look at like a lot of the NoSQL databases, they were kind of I think a step in the wrong direction for kind of many reasons, and there's kind of poor at being a database in a lot of ways. Like you either have, I think like the ones that make sense and that are still kind of seeing uptake in usages are those that are essentially like either just key value stores, which is kind of fine, or like the rest all seem to kind of to move towards the direction of having some sort of a SQL view or something like that, kind of recognizing that maybe this kind of partial way to query them or kind of very programming-like way of querying them, just kind of a step in the wrong direction. And I think that that's kind of absolutely true. And also like this, that we're now seeing more and more often this kind of database inside out. I think like the Kafka people were the first to introduce this term. And that's kind of like, that feels like a sensible way of looking at things. Like I think we need to kind of turn much more things in this entire ecosystem kind of inside out, and that will make much better building blocks than what we have now. And yes, it's kind of like the little things like, making ETL just kind of nicer and just like figuring out things from the shape of your data. Like I think one area that's also kind of gotten neglected in the, I guess kind of this, you have this kind of pendulum where maybe like in the 80s, like early 90s, kind of all this focus on the ontologies and like the shapes of your data and stuff like that. And now then this pendulum swung the other way with NoSQL and like schemas, and now we're kind of, I guess, moving back more to the kind of middle. But there is value in having things such as like very well-defined schemas, and not just schemas, but actually like kind of ontology that maps onto your domain, because then you can do much better inference about your data than you can if you don't have those things. And this is like, I mean, we're now playing with something like doing some steps towards automated ETL with Metabase, just for the kind of reason that like you would want to kind of do an analysis which currently the shape of your data doesn't really allow you to do. And instead of saying to people like, tough luck, go and rearrange your data warehouse, we just kind of want to do, maybe build a couple of maybe materialized views for you to allow you that. And it turns out that kind of problems like this, like heavily pivot just on the question of how well do I understand the data that's there. So like we're spending a lot of time just kind of building our internal ontology of what our users' data is, and kind of trying to kind of classify the various fields you have and figure out what's there. So because once you have this kind of an ontology, it's much easier to do this kind of reasoning. And then like a lot of the ETL then become, like once you have a solid ontology, a lot of the kind of ETL problems just become kind of a question of essentially transforming one ATS or whatever, like one DAG to another one. And it's kind of, it becomes something that computers are good at, and also like that we as programmers are good at and can do. And so I think like I'm pretty certain there can be like pretty fundamental shifts in how we work, but they might not come from the kind of the most obvious ways. Like, if I'd have to kind of put my bet, like I don't think that maybe like the state-of-the-art machine learning is going to be what's going to be kind of powering the changes, but rather kind of the small shifts in what kind of affordances do we have in terms of the building blocks from which we're building our solutions that will kind of open up new venues of how we can work with things.
There's a lot to unpack in there. John, you had a reply to the NoSQL database comment, I think. I'm picking the most controversial and
Sure.
strongest statement that Simon made.
I was going to ask Simon actually to clarify, where do you see the problems? You mentioned that we're going the wrong way with NoSQL, and then I think you sort of mentioned that key value is the right way. So just want to understand the nuance.
Just in, like, I guess in the classes of NoSQL databases, those that just kind of are essentially, like, I don't know, RocksDB and stuff like that, which is kind of a key value store, and they're like very good at it and like massively scalable. Like this is definitely kind of a building block I think we need, and I can see like then those being kind of, I mean, even like Crux uses, right, Rocks as the So this is like a wonderful use case, and I think we're going to see more of that going forward. Essentially, kind of this Russian dolls approach to kind of building databases or systems, kind of layering them on top. But like systems, I don't know, like maybe like Mongo. I know this is kind of a beating a dead horse, but it's a good example to kind of illustrate the problem. It's just, like if you want to do you can do a lot of data manipulation in Mongo, but you have to use their kind of this JavaScript query language, which kind of is limited in some ways, and they have just like senseless limitations of, okay, like this, like you can't have this kind of operation in a projection state, and then you can have like, all those things, which just shows that it kind of was the whole notion of manipulating data was kind of tacked on and kind of added as the system evolved and more people were using it. And now
I'm going to take a very controversial stance and actually defend Mongo here. Okay. So I started using it, I don't know, 10 plus years ago probably. I was dealing with like strange arbitrary tree-shaped data, and I didn't know what the shapes would be ahead of time. And putting those into a relational database is, of course, ugly. You can do it, but it's expensive. So being able to just take this big tree-shaped thing with arbitrary branches and lots of weird stuff, throw it into a database somewhere, and then recover those things. Like all I was doing was storing them in, persisting them, and then querying to get them back out. I was doing all the manipulations in my programs. So I didn't care about the limited features of MongoDB. I just wanted persistence for weirdly shaped things. And actually it was beautiful for that.
Okay, fair enough. But like, I guess this was like a bias that I wasn't kind of explicit with, is that in general, I'm a big believer in kind of trying to co-situate, or whatever term you want to use, like as much computation as you can, like with your database. Like I think that a lot of the kind of completely unnecessary complexity we incur when building systems to work with data is if we kind of just use databases as this kind of dumb persistence layer and then do all the kind of logic and computation in our applications. Like having said that, there's also like there are problems with that approach. Obviously, I'm not kind of just now advocating for having massive stored procedures, because that's going to just
that's
suck.
almost the opposite of what John was saying earlier about breaking these concerns apart and having persistence dealt with separately from everything else.
Yes and no, but like if you look at systems like Kafka, like the beauty of it is, and now they have like Kafka streams and things, is exactly that they're doing that. Like they're putting computation where your data also is. Like yes, it is kind of slightly different than what we used to call the whole database inside out, kind of coming back to that. But like fundamentally, like, you put all those bits and pieces into roughly kind of the same place, and that I think like makes much more sense, because you don't have those kind of otherwise completely arbitrary boundaries between, okay, this is kind of my data store, and then I load data, I can transform it, save it. Like this is kind of needless friction, and oftentimes you also just have performance limitations or concerns around something that shouldn't be happening in the first place. While if you kind of push the computation more towards your database side, a lot of this just kind of falls apart, and I think you end up with a much more elegant architecture, and it's also like just kind of more extendable. But of course, current systems like aren't quite there yet, to be honest. Like I think that this is just because now we're talking about like the future, and I think it's kind of fundamentally the right approach, and I think we're going to be seeing it more. But also, yes, if you're just kind of locked into kind of I don't know, having some SQL database, it is kind of limited. Even though like you now have, I don't know, like it's a Green Plum or something is called like for Postgres, that we can do like just basically Python within your database and things like that. Like people are playing with that, and like this notion has been around, but I haven't seen kind of comprehensive systems that really kind of make me feel like this problem is kind of solved. Like actually, like, Datomic is quite good at this, even though like it has other issues and maybe not as general purpose, but it again, like it pushes a lot more computation. Like it makes database smarter, but not in a way that feels kind of tacked on, but it's kind of this like computation is actually like a first-class, like a very general way of computing is a first-class citizen in Datomic, and I think this is kind of a very powerful building block. That's why kind of Datomic is awesome for building these applications, because this is exactly like what you want, rather than having this arbitrary limit or boundary between the two.
I think one thing that was in common with each of your answers was reducing the friction around data, dealing with data, and questioning that data, getting answers out of it. It seems like you're each seeing that friction in slightly different places, and hence what you want to see in the future is slightly different things in some ways. John, Morri, did you have a reply to?
No, I mean, I was just going to paraphrase Simon really easy. Sort of saying that Datomic and tools like that, they allow you to, instead of the old school way where you put your logic into a stored procedure to get it close to the actual data, now you can bring the data closer towards you.
Right.
Because you've broke apart that sort of data fabric. The event log is different, and the data is pushed towards you. And then the elegance of the architectures is going to be better because you can do more things when you've got that data at hand. There's less complexity where you're sort of doing more kind of across the wire and the performance concerns.
Yeah, and maybe you can express the computation that you want in a more natural way because you actually have it on hand rather than having to talk through some kind of database API.
Yeah, so a classic example is if you're using Mongo, it's like, you might sort of want to do 3 or 4 queries, and if you're going to do them against Mongo, you have to send them over the wire in a sort of funky script thing to say, go and do this in Mongoland and then come back to me with the answer. But if that data's at hand in your process, there's a bit more flexibility. You can break those queries up.
And the reason, in my case, the reason I liked it is that I had relatively small amounts of highly complex data. So I could actually just pull the entire database or everything that was relevant into my process, deal with it programmatically, where I can actually manipulate that data, in a very nice, easy way, rather than having to use any kind of external interface. And I think I got spoiled by that, and that's all I want to do now. I don't want to have to express my computation in a form that some other system can understand. I want to express it in the program that I'm writing.
Yeah. I mean, it's weird, right, to have like these kind of central sort of databases, and everything's under lock and key, and you have to play by their rules.
You have to take something that you could express easily in Clojure, for instance, and convert that into SQL or something, and then ship that over the wire in order to get the get the results that you want. That doesn't make any sense.
That's difficult. Yeah.
I maybe have a perspective from the kind of production at pretty high scale. Like, on the one hand, I agree it's often the best thing to push your computation to the database. From an efficiency point of view, the database usually writes pretty optimized code. It's going to maybe do a better job than you're going to do once you get it into your Clojure app. But the other side is suddenly you can be sending stuff and that database will stop working, right, for everybody. So, we have things where maybe an aerospike cluster suddenly becomes unresponsive, and it's because someone has pushed some kind of, they have some kind of primitive map reduce operation that you can send to the key value store. And so I think there is a trade-off to make, and I just wanted to bring like the production aspect of it. So it's sometimes safer just to say, well, the database does one thing very simply.
Right.
You can stream the data to yourself and do what you want with it.
In some ways, I
it's
think
safer.
Yeah, I think we're all kind of saying the same thing. It's just a question of what we mean by database in some sense, right? And if we redefine that term somehow, and then I think what we are all saying is we should do the processing where the data is. It's just a question of where that data is. And I think we're also all saying maybe that data should be in a slightly different place than it is in our standard architectures right now. Nick, do we have time for questions? Or okay, so we've hit our time limit. So thank you all so much. Thank you all.